Hello, everyone. Good morning. Thank you for having me. It's my first time at Berlin, my first time at Droidcon as a speaker, and this is my first tech talk, so I'm pretty nervous. My name is Nelson. I work for Embrace. I'm Argentinian, if you didn't notice. We are pretty famous a few months ago. And I'm the engineer manager of the Android team at Embrace. At Embrace, let me tell you a little what we do. We collect a lot of data. We are a data-driven toolset for mobile experiences to improve mobile experiences. And we collect stuff like device data, memory usage, startup time of your app, background activity, the network calls, and as you can see in the screenshot, we display that in a timeline with all the data so you can understand the behavior of your users. For example, in this case, we have a custom moment that starts at some point, and it says it was slow. You have the web view that was loaded and the network call that was executed. We also collect ANRs and your ANRs and third-party ANRs in order to improve the performance of your application. And that is why I wanted to give this talk, because something I noticed when I joined Embrace was that I am not doing an app anymore. I'm an SDK developer, and what we call also is like a platform developer. So when you are an app developer, you write code for your app, but when you are a platform developer, you are writing code for another app. It will be, your code will be part of every app's code. It's like you are the guest in another developer's home. So if you think about very popular SDKs or libraries like OKHTTP or Picasso from Square, probably they have more active users than all your apps together. So, because, of course, their code is part of the code of your app. And that was the reason that I wanted to give this talk, to share my experience becoming an SDK developer, because there are some things that you usually consider when you are doing an app, but they are way more important when you are doing an SDK. And also there are some things that you never consider, and you should take care about that. And these are the three topics that we are going to cover. The first one is developer experience, which is how a developer will interact with your library or SDK. And the second one is what I call performance, is how your code, your library will behave in the developer's app. And the third topic is like how you ensure that you're a good guest, that your code will behave properly in another apps. So let me talk to you a little about my history first. I have been an Android developer since 2012, a lot of time. Android 2.2 was my first experience. And over the past decade, the rise in mobile was huge and created high expectations from end users. And that created a demand on complexity that we need to meet. And it's very important as developers to meet those expectations. And in my entire career, I've jumped in many different industries, always doing applications, e-commerce, food ordering apps, transit applications, car ride, and so on. But always while doing that, I was kind of in a journey of looking for quality in software, what it means, and how to ensure that the software I write is executed properly and make my life easier and other developers' life easier. So in my last few jobs, I started to move to internal SDKs or libraries, and then I learned a little more about performance. And finally, I joined Embrace as engineer manager. This is a meme a friend sent to me when I became an engineer manager at the team. And when they offered to join me, I really loved the idea of becoming a developer for developers, that my customers or my users are now the people that do what I used to do. So I want to make a clarification before starting that for the purpose of this talk, I will use the word library or SDK as if they are the same, which is basically a piece of software that isolates functionality so other developers can use it and can focus on the product that they are building. And, well, the first topic is developer experience, which is how a developer will use your SDK or will experience the integration of your SDK in their own code. So that your SDK needs to provide a way for developers to use it easily. And this includes 4 topics, which is the public API, the versioning of your SDK, the documentation to use it, and the dependencies that it includes, dependency management. For public API, one of the most important things is to be consistent and clear on the naming of the API and the classes, the methods, and the parameters that you are providing to all the developers, and following established patterns and convention on the platform you are working for, in our case, Android. So the idea is to have an API that is fluent, intuitive, and familiar for developers. For example, on Android, we are pretty familiar with the listener or callback pattern. So for example, in Glide, when you need to know if the image was already loaded, you have the listener for that. Another practice that is very common on SDKs for Android is use the singleton pattern. So you use the get instance or the .get to get the instance of the SDK. That's something that any app developer will expect to use. And also, in terms of consistency in the behavior in your entire SDK, the idea is that any developer should be able to predict and understand how your components will behave. If they are using feature A and they know how to use it and you release feature B, it should be easy for them to understand that it will behave the same way and configure in the same way and so on. It will reduce the cognitive load and improve their performance if easy for use. And finally, I want to talk about keeping your API simple and focused on the usage. For example, for Picasso, they had this method chain pattern to load the image, resizing it, transforming it, and load it into the image view. So it's pretty easy to read and understand. And again, focusing on the use case is pretty important. And I want to tell you about a story about what we have a few weeks ago in a feature that we are implementing. As I told you, at Embrace, we collect many data, including crashes from the session of your application. So we want to expose an API that tells you if the previous session, the previous execution, ended with a crash. In order that in your application, you can say, OK, if the last session was a crash, I want to give a reward to the player if it's a video game, or resume the transaction if it's a fintech, whatever you need to do. The first iteration or the first idea was to implement an enum with 3 values. Why? Because we discovered that in some scenarios, we don't know exactly if there was or wasn't a crash. So that we decided to be realistic and expose the result as there was a crash, no crash, and then no, we don't know. But then in a second iteration, we started to think like it's kind of complex, or we don't want to give that decision to the user, to the developer, because actually the use case for the developer is they want to know if the previous session ended with a crash. They don't care if we don't know or there is no crash. The idea is, did you have a crash? Yes, then they can behave differently. So this was kind of an easier and simpler API for them, and this is a very nice example of that. And the 4th part around public API is the customization modularization. Modularization of your SDK will allow developers to select which components they want to add, which parts of your SDK they want to use. They can handle properly the size of their own app by selecting which part of the SDK they will add in. This is an example for those that are old as me of the support library of Android. There used to be one library with all the support features, and one day they split it This picture is from Jetpack, but it was before Jetpack. They split it in different behaviors like life cycle and camera and whatever. So this is an example of how you can split your features so the developer can choose whatever they can use. And the next topic after public API is versioning. Once the developers know how to use your SDK, they need to choose which version to use. And for that, I discovered one thing that is the main difference between apps and SDK, that is that all versions of your SDK will remain available forever. Why? Because first, Maven doesn't remove artifacts. You are not allowed to remove artifacts. So if you are releasing a version with a problem, it will be available forever. And if a customer decides to use it, a user decides to implement that dependency, it will remain there forever. So that you should ensure backward compatibility. This will allow developers to upgrade new versions of the API seamlessly without avoiding them to modifying their code base every time you release. An important advice is to create migration guides from very old versions to newer versions, because you don't have control on which version are your customers or users. For example, if you are about to release version 4, probably someone is still using the version 1. So you need to create a migration guide. Will be really helpful for them, because the transitions between versions is pretty difficult. And another thing around versioning is that, not in this room, but there are developers out there that they don't have a fully CI/CD app compliant, and they do a manual regression every time they release the app. If you are releasing a new version of your SDK that doesn't ensure backward compatibility, they will need to do a manual regression every time release. So they will avoid upgrading the SDK. So that you should make sure that every update doesn't include regressions or new problems. How to make the version easy to understand which changes are you proposing in each version is to follow Semver. Semver means semantic versioning, and it's a standard that will protect you from some mistakes in which changes are breaking changes or not. It works like this: 3 numbers. The major one is a breaking change. The minor is a new feature that you are adding, so it's easy to move from one version to the 5.1 to 5.2 because you are not breaking any changes. And the last one is because there was a patch that you need to release. On top of that, there are some tooling that you can add to your project. For example, the binary validator. It will validate your API. It will prevent unexpected changes on your API. It basically is a Gradle task that you run on each PR. You can run on each PR. It creates a text file, human readable, that you can include in your repo. And if someone creates a PR that changed that public API, it will compare the golden file and throw an error. It works like this. You have 2 tasks. The first one is API dump to create the file that will review all your public API methods, create a text file, and add in it. And the second one is API check that basically will compare the text files and say, hey, this PR is breaking your API. This is how an API file looks like. All the methods, pretty simple. And if you see a change in a PR, you will see a change in GitHub, for example. The next topic after versioning is documentation. It's really hard for us to write documentation, but working on an SDK is one of the most important things, because there are some developers that really love to read documentation to understand how they should implement it, how they use it. And also, there are some developers that doesn't like to read. So an add-on to the documentation should be sample applications and examples. This is pretty useful to have and very, very important. Note around that is, if you have a very good Java doc in your public API, you can implement a tool like Docker that you can execute in your pipeline. This is a part of our GitHub action. You basically run the Docker HTML task, and it will generate a website with all your Java doc. and we expose it to GitHub pages. It's like a very good first step, and you get a website like this with all your public API and the definition that you have in your Java doc. It's a very good first step to start writing documentation. And finally, around developer experience is dependencies. This is pretty important because Gradle has a feature called transitive dependencies, which is that any dependencies included in your component will be moved into the first app dependencies. So that the advice is to consider compile only. Probably you know it. I didn't know it when I joined Embrace, so I wanted to include that because it was really useful to understand the behavior of that. Implementation is what we usually do when we are doing applications. We need a dependency like, I don't know, OKHTTP. We do implementation, com_square.OKHTTP, and that's it. And it will be included. But if you do that in your SDK, the dependencies that you add as implementation will be included in the runtimes class part of the app. It will be part of the POM file. Instead of compile only, you are saying, I want this dependency for build my SDK, but I don't want to include that as a dependency for the app. So you are having faith that the app that is implementing your SDK will include that dependency. It's not part of the POM file. And this is the most important part of this. There is a big trade-off. Why? Because you can have a no such method exception in both scenarios. Why? In a scenario where the application has a dependency on OKHTTP1, your SDK has OKHTTP4 as implementation. What will happen when they include your SDK is that the app will use OKHTTP4. If they are using a method that is not included in that version, they will have a no such method exception at runtime. It doesn't get exposed at build time. So it's pretty heavy. And the opposite, if you expose your dependency on OKHTTP4 as compile only, and the application has OKHTTP1, what will happen if you are relying on a method that doesn't exist on the first version, because it will be the one included in the app, you will be raising a no such method exception. So you need to decide, in case that you are using a version that can raise a problem, who will be the one that has the crash, the app's code or the SDK code? If you're a good professional, you should be taking care of that. That's why I suggest using compile only, unless it's mandatory, the dependency, and handle the different versioning that they have. That was the first part around developer experience, and now we are talking about performance. Once a developer already is using your SDK, they decided to implement it in your app, they know how to use it, it's part of the app, they release it. Now they will take a look on how your SDK behaves in their app. And one thing that is pretty important here, I mentioned that there are some stuff that you consider when you're doing apps, but when you're doing SDKs are more important. I was thinking on product requirements. Basically, you will be thinking on these 4 topics like startup time, the artifact size, and whatever. But those topics will compete on priority with product requirements, business features or requirement from customers or whatever. When you are doing an SDK, all these features are product priority. Why? Because there are some stuff that many customers ask us. I learned all this because of experience, customers asking things or problems we face with my team. And I group all those things in these 4 topics. And it's usual when you are evaluating for an app to use an SDK or which library I will implement, the first thing everyone asks us is the size of the artifact, for example. If you are working or releasing an app in an emerging market, of course you are very careful of the size of your app. And if you're adding a dependency, you will be very careful about the size of that dependency. That's why for us SDK developers, it's really important, it's a product requirement, the performance of your SDK. The first thing that you get on resource usage is, of course, CPU, memory, and disk. And the idea on those things is you can measure and put thresholds on how much, what are the values that you want to constrain. An activity that we do at the company to make sure that we are achieving our goals is what we call, is called fitness function. And the idea is to run tasks on each release, on each PR, if it's possible, to see if the current values around these topics are crossing the threshold. For example, the size of the APK is evaluated every time. If you are adding a new feature that increase the value, we will notice with those fitness functions. For that, we use sample apps that run in the cloud, like Browser Stack is the tool that we use. We run many, many scenarios, we collect the data, and we have some numbers to evaluate the thresholds. But a particular topic around resource usage is data consumption. And I mentioned this particularly because I want to tell a story that we had a few months ago with a customer, a difficult story. We usually, when you are doing apps, you are relying on the user data plan for consumption, the Wi-Fi or the plan they have, the chips they have. But in this case, there was a customer that has a GPS device. They provided a GPS app and the device to the truck drivers. With that device, they had a data plan that was pretty cheap because it was part of their cost. And we realized after some evaluations that we were consuming half of that plan in a month. And they were very worried about that. And for that, we realized, OK, not always is the end user the one that is in charge of the data that we are consuming, but also the customer. That was really, really important for that. And it's a use case that we never consider. If you are if the application is a video game, it will rely on the data plan of the user, and usually it's run on Wi-Fi or a huge data plan. But for this use case, it was really unexpected. Sorry, artifact size. There are some practices that we'll do when someone complains about the size of your SDK. It's like, this is too big, we cannot use it, or it's more than you expected. You will review all the dependencies and see which ones are the most difficult ones, are the one impactful on the size of your APK. You will replace it, like JSON for Moshi or whatever. And of course, removing an edge code. But then if you want to reduce even more, it's really hard to have impactful things after you get in a good shape. I have a few suggestions and advices that we are doing for that because we want to achieve some minor tweaks into the size. And one thing we discovered is the use of data class. When Kotlin released data class, it's like we all love it. We use it a lot because, of course, you have a value object that's instantly created. You can compare it, create it, and that's it. And the idea of this advice is to review the overuse of data class. Because there are a few methods like toString or equals that will be created, and it won't be removed by the obfuscator tool, but ProWare or whatever. So it won't, if you have a lot of data classes mapping your payload, for example, but you don't use the compare, it's useful to remove the data class and use a regular class. It will save you a few kilobytes. And another one is to review the ProWare rules. I didn't put an example here because it's very particular of each case of the SDK, but in our case, we reduce 6% of the size just by tweaking the ProWare rules on which things are minified and which things are not. The next topic after artifact size is startup time. When a customer approaches us and says, what's the size of your artifact? Is 600 kilobytes. Okay, and what's the startup time? It's really hard to measure, but it's really important for many applications to measure that. What I mentioned is, in our case at Embrace, as we collect many data regarding crashes, NDK, ANRs, even startup time of your app, we need to be implemented at the very beginning of the application class, kind of the first thing that you need to add. That's why we are impactful on the startup time. And the first thing that we are doing is to deferring anything that we can to a later point in time and moving things to background. And if you saw a few days ago, Ahmed did a presentation on baseline profiles. He mentioned around 20% of improvement. It's really important really useful to implement baseline profile, and there is a lot of data on the Android website. And on top of that, what we do is to run the benchmark. We run it on the cloud, like I mentioned, in browser stack. You can measure the startup time in many different devices, in many different sample applications, and the benchmark tool will collect that and give you a number. And that fitness function, you will have a number every day after we do it nightly. So we have a number every day saying this is the median startup time that we are having today. And finally, crashes. You should avoid crashes at all costs. It's already awful enough to have crashes in your app, and seeing crashes from external SDK for a third party is like if you install Embrace and see there is a crash from Embrace in my app, you will kill me. You will find me and kill me. And that's why you need to avoid crashes at all costs. One suggestion is overuse of try-catch, of course, and capture everything you can. And on top of that, when you are capturing errors and exceptions, you should be careful of the logs that you're exposing, because the idea is to let the developer to solve the problems. You don't want them to create issues on your GitHub repo or your customer support system. This is an example that we have. When we create, there was a method that was throwing this log error in logcat, and when we did it, I discovered that this message was a debug error for us. We put it, and the developer will add this text, so they know the problem, but not the user, our developers. So we changed it to something like that when happen in production or at build time in the developer's code, they can know what to do with it without asking us or raising an issue or being blocked. So logs are very important. But, which brings us to the next topic, to ensure performance over time, to say we are good guests in the other developer's house, that our product offers good quality, my recommendation is to build a team of developers that follow good practices. And that is where software craftsmanship, for example, comes to light. There are a few other modern ideas that I suggest you to follow. Basically, software craftsmanship was born to raise the bar for professional developers by practicing and helping others to learn how to craft well software. And the idea is these are the 4 principles of software craftsmanship. Be product partners with your customers, understand them, interact with the community, with other developers, and the most attractive one is the first one, that is not only working software, but also well-crafted. There are another best practices like following the solid principles, that the idea is to create a software that is easy to use, easy to change, and easy to test, because quality should be the first thing you do when you are doing an SDK. There are another set of practices exposed by extreme programming, as I mentioned here. For example, pair programming or TDD will help your team to develop be in a good shape. A few that are very practical to present for SDK APIs are avoiding the primitive obsession and using the builder pattern, for example, is very popular in the SDK world, for those who doesn't know. Primitive obsession is the smell, which is the overuse of primitive data types, like integers, strings, and so on. Instead of that, the idea is to use custom business objects. This is the case of OKHTTP, for example, that I guess everyone uses it. The request body, instead of using just the string as JSON, you need to create an object with the media type above. Instead of using the string of the media type, you create an object of the media type, and so that you create the request. The builder pattern that is composed with that in that example is a design solution to create objects, basically. It's a design pattern to create objects. And as we can see here, the request builder take an URL, the body previously created, and will build an object and return it. So, to summarize, the key takeaways of this talk around developer experience: take care of the API on the conventions and consistency. Stick to Semver. It's pretty important to use Semver. The documentation is the hardest part for any developer, but it's one of the most important things you need to take care about. And of course, always consider compile only. This is like, please always consider using compile only. Around performance, I will suggest to implement fitness function to measure the status, the state of your library on every PDR, on every release. Check the consumption of your data so you don't face the problem that we faced, and let the developers solve by themselves the error that they are experiencing. And finally, be a good guest, be a good professional following the software craftsmanship principles, and that's pretty much it. If you have questions, you can talk now, or you can find me in the Embrace booth. It's right next to the BMW. I guess you all see it. And, well, thank you.